Hello, thank you for joining us. Today we are going to run through a demonstration of how to use Tensorboard with RunAI, and we'll also use ResNet as an example. Okay, so what is needed for Tensorboard to run? You basically just need a folder. You need a logs folder to store all the objects related to all of the runs, and that is it. Outside the software, you just need a folder. And so how does Tensorboard work? Well, one, to view the Tensorboard UI, we have to start the server with a CLI command. It is this one. We just started with Tensorboard. We also have to specify the path for our log directory, and we can also add a host or port. And then in order to write records to the Tensorboard folder, we have to create a Tensorboard callback in our script and pass it to the model. So here this is our folder path, our logs directory path. And then we create the Tensorboard callback object and specify our Tensorboard path. And then we just stick it in our model as a callback, and then we fit. It is important to note that you do not need to start the server in order to write TensorFlow records. You only need to start the server in order to view the UI. So how are we going to run Tensorboard with RunAI? There's three things that we're going to need. We're going to need a persistent directory to keep the Tensorboard logs folder. We'll also need an image with Jupyter Server Proxy installed. This is how we're going to access the UI. And of course, we also need an image with TensorFlow installed so that we can actually train our ResNet model. So before we begin anything, we have to create this Tensorboard logs folder on our NFS. Now, currently my NFS looks like this, where I've got this data folder and projects folder under my main directory. And this is the default folder structure for a JupyterLab image, where we've got the work directory here. And so what we're going to do is when we create, we're going to start an interactive session and just mount our NFS directory onto this work directory. And then we're going to actually create that folder. Once we mount the NFS, this is what our directory will look like. Under the work directory, we'll have our data and projects folder. And then we're just going to use the JupyterLab UI to create the Tensorboard logs directory. And of course, because it's an NFS, this will be created on my actual directory. So let's go ahead and do that really quick. So I'll go ahead and start a new job. It'll be interactive. And it doesn't matter which one we use. I'm just going to use a base notebook, no GPUs. But the important thing is to have our storage volume, our NFS path mounted onto the work directory. So let's go ahead and submit that. We'll just wait for that to start up. All right, now we're good to go. We'll go ahead and connect. And we'll go to our work directory. We see all of our folders there, and we're going to go ahead and click the new folder button and Tensorboard logs. And that is it. Once we do this, we can just go ahead and delete this job. And we can continue. So in terms of Docker images, we're going to use two. The first one is going to be the Tensorboard-UI image. And this is what the Docker file looks like. It basically pulls a notebook with the Jupyter Server Proxy already installed. Then we go ahead and install Tensorboard, and we replace the config file with a new config file. And the config file will have this particular entry added to it. It's very important. It's this c.serverproxy.server. And the key thing to note here is this particular line. We're going to make the log directory, that Tensorboard logs that we created, under the work directory. We also need this IP end port. And of course, we have to tell Tensorboard that port 6006 is where we're going to have that URL point to. And the second image is going to be the keras-nb. And so this is what it looks like. We just pull a Jupyter a Jupyter image that we created. We'll install CUDA Toolkit, then we'll install TensorFlow, and we've got to actually set this environment variable so that TensorFlow actually runs. And so in order to access the UI, we're going to create an interactive job, but we're going to use the Tensorboard-UI as our image. And of course, as always, onto our work directory, we're going to mount our NFS. And then we're going to access the Jupyter Notebook, and we want to make sure that our Tensorboard logs folder is there. And finally, we're just going to go ahead and click the Tensorboard tile to launch Tensorboard. So a new tab will appear with the UI. And I always like to make sure that the reload data button is on. Important to note that the first time you start this, you're going to get like something that looks like an error, but that's just because there's no, there's no files in the logs directory. So that's normal. Let's go ahead and do that. So we'll start an interactive job, and we will make sure it's a Tensorboard UI. We don't need a GPU because we're just reading the UI or just using the UI. And of course, our storage is going to have the usual NFS mounted to the work directory. So we'll submit that. Okay, we're good. So let's go ahead and connect. Okay, so our folder is there. So we can go ahead and click the Tensorboard icon. And like I said, we have no data, so this is expected. And I'm just going to go ahead and put a side-by-side view here. Now I'm actually going to go ahead and test this. So I'm going to go here and I'm going to create a notebook with our Keras NB image, and I'm going to give it 1 GPU, the usual storage setup where we mount our directory onto the work directory, and we'll go ahead and submit that. We'll just wait. Okay. And let's go ahead and connect to that. Now, inside of my projects folder, there's our Tensorboard ResNet demo, and I have this test Tensorboard. And so I'll just go ahead and run all these cells here. Okay. So if this is updating, yeah, this is updating. So every 30 seconds is going to reload. So I'm not going to touch it until we get our first reload, just to show you that it, oh, there it is right there. Perfect. And so every 30 seconds, this will reload. If I wanted to get sooner, like updates faster, I could always just click this button and you can see that it updates up to the latest epoch. There's other things we can look at, the graph, distribution, and of course, histograms. Sometimes one or more of these might not load correctly. If that's the case, you can just hit the refresh button up here and everything will load as it should. So, yep, good. So all of this works. I'm going to go ahead and stop this and go ahead and delete this notebook because we no longer need it. And let's move on. Okay, so now we're going to try to train a couple of ResNet models. Let's quickly go over through the scripts. So the first one, we're going to specify where our Tensorboard logs folder is. We're also going to create a project name. We'll pull a data set from TensorFlow. It's a flowers data set. And then we'll use the TensorFlow API to pull the ResNet architecture. And here is where we create a sort of subfolder. And we're going to basically, under our Tensorboard logs, we're going to create a folder called ResNet 50. And then under that, we're going to put the current date time in order to distinguish this particular run. And then, of course, we just put this in the callback, fit, and save the model. And so since these are our Python scripts, they're under the Tensorboard ResNet demo, under projects, and under work. So this is what our CLI command would look. It would look something like this, where we, first of all, specify the keras-nb Docker image, because that is where our TensorFlow is actually installed. We have to make sure, again, we mount our NFS onto the work directory. And finally, we have to specify the ResNet Python script and make sure that we, specify the relative location within the Tensorboard ResNet demo, under projects, and under work. And so once I submit this command, I should see a new job appear. And then basically the Tensorboard UI will refresh periodically. So let's go ahead and do that. These two commands are the same, minus the last line. This is ResNet 50, this is ResNet 101. And so I'll go ahead and submit ResNet 50. Okay, says the job was created. So let's just make sure. Yep, it is there. So now we can submit the second one. And we have the second one. Excellent. Now this does take a little bit to actually train. So I'm going to go ahead and pause the recording and then come back once they are finished training. Okay, so both of our jobs have succeeded and everything is up to date now. So if we write ResNet here, we can actually filter for our particular graphs. So yep, we can explore all of these tabs all we want. So what was going on there was that basically as our models were training, they were writing files into this Tensorboard logs folder. And basically the Tensorboard UI every 30 seconds just looks into this folder and it reads it and it updates. If you wanted to, you could manually press the refresh button and it would, read that the folder right then and there and update the UI. There's one more thing I want to do just for the sake of completeness, and that is to run a little inference just to make sure our models worked. So we're going to use the keras-nb image again with 1 GPU, and we'll go ahead and submit that. All right, and now that we're running, we can connect. Go into our projects, our demo, we can see the two models are saved here. And we'll go to this predict ResNet and then just run all of these. And so basically what we're doing here is we are just loading ResNet 50, the model that we trained, and then we're going to plot some predictions. And we'll do the same thing with the ResNet 101 and plot some predictions. It's probably easier if I turn this off. Okay, so here, this is ResNet 50. We've got sunflowers. That's good. This is supposed to be a rose, but it was classified as tulips. And the ResNet 101 got that sunflowers right. And also misclassified this particular rose. So both of these definitely need a little bit more training time. But yeah. And that is all. Thank you so much for watching.